Hey guys, we're going to talk about 1 and 2 steps equations. We talked about translating equations. Now let's talk about solving 1 and 2 step equations. So there's a couple things we need to know before we solve 1 and 2 step equations. When solving equations, you got to work backwards. So go ahead and write backwards in the blank. So instead of thinking PEMDAS, the way in which you solve equations, you'll use SATMAP? No. Well, you'll just think subtraction, addition first I'm going to get rid of. Then division and multiplication. I work backwards, okay? The other thing you're going to do, you're going to be working backwards, but you're also going to use inverse operations. So while working backwards, you must perform inverse operations. So go ahead and write inverse in the blank. Now what inverse operations means is that you're going to do the opposite of what you see, okay? Every time I see addition, I know I'm going to use the inverse of addition, and that's just subtraction. So write that in the blank. Every time I see subtraction, I'm going to do the inverse of subtraction. I will do addition. And every time I see multiplication, I will do the inverse of multiplication. I'll do division. And every time I see division, I'll do the inverse of division. I will do multiplication. Now, here's the thing, guys. I call this the great undoing, because what you're doing is doing these inverse operations to undo and get x by itself. You have officially solved an equation. Okay, so it is solved when x is by itself. So put I've solved when x is by itself. Okay, write that in big letters. You have did the great undoing. Okay, if x still has a partner, you have not undid. Okay, with that being said, guys, let's go to the next part. Okay, the great undoing. I want you to watch Miss Bennett in action as I show you what I mean when I say inverse operations. We're going to do this with addition, subtraction, multiplication, and division. Now the key here, guys, is that what you do to one side, you have to do to the other side. We just watch. You know, Miss Bennett, I love my vocabulary. So we just watched the vocabulary, and we watched the importance of keeping everything balanced. That's what we have to do. We're going to do the great undoing, doing inverse operations, and we're going to keep things balanced. So it tells me to solve x plus 2 equals 3. X has to be by itself. And I see addition, so I'm thinking inverse. Inverse is subtraction. Look back at your list. Addition, subtraction when I'm solving. So x is added to it, so I am going to subtract. I'm going to write the subtraction in there. I'm going to subtract 2 from both sides, and that's what I do. So I am going to subtract 2 from both sides because x was added. I'm thinking inverse operations. Once I do that, I get a solution. On the left side, I got x by itself, so it goes away. On the right side, I get a 3 minus 2, which is 1. Okay, great undoing. I got x by itself, and I know it equals 1. Let's go to the next one, subtraction. Again, I'm thinking inverse. X is being subtracted. There's a subtraction. 2 has a subtraction sign, so I do inverse of subtraction, which is addition. I would add 2 to both sides. So I'm going to do that. I'll add 2 to the left of x minus 2 equals 3, and then I'll add 2 to the right to do that balancing. On the left side, look at the left. Notice the 2's cancel. On the right side, I got a 3 plus 2. So I know x is equal to 5. Okay? Multiplication. Again, I'm thinking inverse operations. If I see multiplication, 2x equals 8, then I know I need to do the inverse, which is division. X has 2 multiplied to it, so I need to, in the blank, I'm putting a division sign. I need to divide, okay? So I'm going to divide by 2 from both sides of the equation. So I divide by 2. And how I'm going to do division on here to show you, I'm going to make a fraction. Remember, fractions is division too. So I'm going to say divided by 2 like a fraction on both sides. Now, if I notice to the left side, 2 divided by 2 is 1. They actually cancel each other out because they equal 1, right? So I end up with x, so 1x. And on the right side, 8 divided by 2 is 4. So I know x equals 4. The great undoing, okay? You're undoing things from one side and you're figuring out a solution on the other side. All right, last one. It says solve x divided by 2 equals 8. Well, I see division, so I'm going to do the inverse of that, which is multiplication, inverse operations. Okay, so I am going to multiply by 2 on both sides. So on both sides, I am going to multiply each side by 2. So I'll write my 2 here, okay? And I'll write times 2 over here. Well, on the left side, if I multiply a fraction by 2, again, we have the same thing that happened over here, where the 2's have to cancel each other out. So I end up with x, and on the right side, 8 times 2 is 16. So I know x equals 16. Again, inverse operation, guys, and doing the opposite is how we're going to solve these equations. So let's do some practice. Okay, so they give us some problems, but we're not scared. We think inverse operations, and we're doing the opposite of what we see. So for number 1, m plus 12 equals 10. Well, I see addition, so I know I need to do the inverse. I need to subtract 12 from both sides, and I need to get m by itself, okay? So when I do that, guys, I carry my equal signs down. 12s go away. 12 minus 12 goes away. So I have m, and it's equal to 10 minus 12. Again, that is going to be a negative value, right? Because 12 is negative, and I'm left with a negative 2 if I subtract those, all right? M equals negative 2. Over here, I need to solve for g. I see subtraction, so that means I do the inverse operations. I add 9 to both sides. Again, I got to keep it balanced. Add 9 to both sides, and I end up with, on the right side, the 9's go away. So I just have g, and then on the left side, it equals 7. Okay? On number 3 is negative 7y equals negative 91. Well, I am going to go ahead and divide because I see multiplication. Okay, I see multiplication here, so I need to divide both sides by negative 7. Okay, when I do that, again, the 7s cancel out, so I end up with a y. Then I got a negative 91 divided by negative 7. I know that's a positive value. And if I plug that into my calculator, I would get a positive 13. So y equals positive 13. Over here on number 4, I see division. So I know I need to multiply. Okay, if I see division, I need to multiply. So I am multiplying 9 times a over 9 on the left, and I'm multiplying negative 4 times 9 on the right. Okay, so I am multiplying. And what I want to do, if I look to the left, I notice the 9s are going to cancel. So I'm just left with a. And it's going to equal negative 4 times 9. Well, that is just negative 36. Okay, so a equals negative 36. Again, the great undoing. All right, so now we have one-step equations with fractions, and we're not afraid of fractions either. We don't care about fractions. To get rid of fractions, guys, I want you to multiply by the reciprocal, or the flip of the fraction. Okay, it's called the reciprocal. Go ahead and write that in. All right, so reciprocal, make a note down here that the reciprocal just means the flip of the fraction, okay? So if I look at number 5 and I see a fraction 2 over 3x equals 10. Again, this is a fraction. I'm going to multiply both sides by the flip of that, the reciprocal, 3 over 2. I took the fraction and I flipped it. Now, if I did it on one side, I got to do the other side. So I got to say 10 over 1. And Miss Bennett's going to give herself some space. So I'm doing 10 over 1 times 3 over 2. Now on the left side, everything is going to cancel. It's all going to cancel out and it's just going to be 1. So I'll just have x by itself. And then on the right side, it's going to equal this. Well, remember we multiply straight across. 10 times 3 is 30. And 1 times 2 is 2. So it's going to be 30 divided by 2. 30 divided by 2 is 15. So x equals 15. Now let's go on the next one. The next one, same. We got a 4 over 9w equals negative 8. So I know that that's just going to be a 9 over 4. Okay, so I'm multiplying by 9 over 4 to the left. I'll do the same to the right. Multiply by 9 over 4 on the right. And that negative 8 is over 1. Okay, now, if I look to the left, everything cancels, okay? So I just end up with a w, and it equals, let's look to the right. Well, I'll multiply in the numerator. Negative 8 times 9, that's negative 72. And in the denominator, 1 times 4 is 4. So negative 72 over 4. And I think, guys, we can simplify that. Let's punch it in our calculators and see what we get. Negative 72 divided by 4. Yeah, that's negative 18. So W equals negative 18. All right, let's go to 7. On 7, we're multiplying, we got a negative 6 over 5k equals 12. So we need to multiply by the reciprocal, which is negative 5 over 6. I just flipped the fraction. So to the left side, I'm going to multiply by negative 5 over 6. Okay, Miss Bennett is writing that here, negative 5 over 6. On the right side, I do the same thing, and I'm going to just write it out because I know this is where I'm doing the real big deal. negative 5 over 6, okay? And let's go ahead and multiply this out. Well, on the left side, everything cancels, okay? It's all going to cancel, and I just end up with a k equals, and on the right side, I multiply straight across. 12 times negative 5, well, that's negative 60. And 1 times a 6 is 6. So negative 60 divided by 6 is negative 10. All right, the last one, guys, again, you're going to be multiplying by the reciprocal. I see a negative 1/2, right? So I'm going to multiply this by negative 2 over 1, the flip of the fraction. Okay, so I got to multiply one side, I got to do it to the other side. I'm going to multiply this by negative 2 over 1. And then from there, I'm going to look to the left. I realize everything's going to cancel. The 2's are going to cancel across, the 1's are going to cancel, and I'm just left with a m. Okay? On the right side, guys, we got to multiply straight across. 9 times negative 2, well, that is negative 18 in the numerator. And then in the denominator, a 1 times 1 is just 1. So we know m equals negative 18. All right, guys, that's where we're going to stop with one-step equations. We'll stop right there, and then I want you guys to practice. You are going to practice doing some one-step equations.